Okay, with the start of recording, good evening and welcome to the EVAC meeting for June 17, 2022. Maybe not. And welcome. And tonight we are live and online. So this is our second time for that. Hopefully things work their way through. Assisting tonight are Tom Mosden, who's managing the technology, and James Yoder is helping him. So if you have questions on the Zoom call, send those in through the chat or questions. Which would it be, Tom? Chat. Send it through chat and they will respond to you, and then they can also have a microphone. So if we need to ask a question of the speaker or something in the future, we can do that as well. All right, so welcomes, introductions, our current business. We have a member presentation tonight from Bob Buchheim, and our featured speaker tonight is Frede, who's going to be talking about astrophotography, which should be a great subject. And so for our officers and board, Claude Haynes, your president, VP is open still. We are begging. So if you know of anyone or you would like to volunteer, we are still looking for a vice president. Our secretary is Gordon Rosner in the back, and also our treasurer, Alexandra Nachman. She is in the back. If you have any business or need to buy any of the shirts or other things that we have here. For the board, these are the members. Do we have any board members here tonight? I think, John, okay. But if you, or Derek rather, if you have any questions, please contact us. We would like to hear from you. And then in addition, we have James Yoder, who is our property director. Alexandra is also events coordinator, and Marty Pazanka is our webmaster emeritus and newsletter editor. A couple of things, shirts on the table. Over here, we have shirts. They're individually marked price-wise. They are a good deal, various sizes. Take the tag back to Alexandra if you want to purchase one of those. We also have hats for $10 that are lots of fun. We have a table with magazines and books over there for free to a good home. So please take something with you. At the back table, Brooks also has badges. If you have ordered a badge and you are here tonight and you have not received your badge, please do that. And then Alexandra can help you with treasury dues or anything else in terms of things for the treasurer. We don't really have refreshments. Gordon brought some water tonight in the back. They are free. I would like to take just a brief sample of hands just to know. One of the questions that we've struggled with is the format, because we are doing both in person and Zoom. And so the traditional way we handled this was with business or a short member presentations and things up front, and then maybe 15 minutes of refreshments in the back, and then we would have our main speaker. When we are doing that, that would then give 15 minutes worth of dead time for the folks who are on Zoom, and doesn't seem to work out that well for them. So I have three choices. First, do we return to the usual method of business short break and people can talk to each other and then the presentation? Folks in the room, would you prefer that, going back to kind of that method? Okay, 1, 2, 3, okay, 5. The second one would be gather at 7:30. Yes.
I was just saying that folks on Zoom can take it back and break it in.
That's true, but you can as well. But please go to the restroom down in the middle of the hallway there. Yes, but you're all free to walk around too. Or if you get tired, feel free to walk around. You can sit in the corner. The second would be gather at 7:30 and then have a kind of a session 7:30 to 7:45, and then we begin at 7:45 and go straight through with the presentations and the all of the business, and that way it would be straight through on Zoom. How many think that would be a good idea? Okay. And the third is we aren't here for the buffet, start at 7:30 without refreshments or a break, and we just keep going. Anybody for that one? Okay, nobody for that one. Okay, 3 didn't work. Thank you, though. That was helpful.
Let me repeat those for me and I will do a poll.
Return to usual as business break feature presentation, or gather at 7:30 and start the Zoom at 7:45 and go straight through. And the third one was, we're not here for the buffet. So we just don't worry about refreshments. Yes.
Anything you could do for the Zoom viewers for that 15 minutes, like a short film or something, or broadcast something? Or anything, I'm sure you.
We can have Tom sing and dance. We could do that. But I don't know. Well, that's a thought. Let's think about that one. We hadn't tried to complicate it more, but we might be able to. Yeah, the question would be whether we would be able to do it without also having it pick up the noise or things from in here and that sort of thing. It's a good thought. Thank you, though. Good suggestion. Okay, starting tomorrow, weather permitting and no smoke permitting, the Grand Canyon Star Party. Don and I are going up Monday, Tuesday, Wednesday. Is anyone here? Anyone going? Just so we can, okay. All right, so maybe we'll be able to bump into you and see you sometime up there. Summer family events, June 27 and July 25th. Our next one is Monday, a week from this Monday. 7:30 lecture with viewing afterwards. So Gordon is going to be doing the lecture and then we will do some viewing at the observatory afterwards. And I see an untitled poll. Thank you. And then Bob, we have a presentation from you. Sure. Tom, go ahead while I'm doing this.
We electronically connect with the our members in several ways. The Facebook page, not everybody does Facebook. Then our website, the evaconline.org, AZ Observing at io.groups, and the EVAC announce emails. I'm just wondering how many people visit the Facebook page regularly? Okay, 1, 2, 3, 4, 5, 6, 7, 8. And how many people rely heavily on the AZ Observing at Groups.io for announcements? Okay.
Is that a newsletter?
No. Yeah, that's a chat group with all the people in Arizona talking about where they're going, observing, what's new. Yeah, if you look at groups, what is it? Groups. Groups.io.com. Yeah, if you search for AZ Observing in Groups.io, you'll find AZ Observing and you can sign up. And let's see, the other one is, so there's the EVAC announce. A lot of people have subscribed to that. How many people are subscribed to EVAC announce? Okay, quite a few. That's good. Recently, I've just taken the emails in EVAC announce and sent them from my personal email so that people can reply to that. Because if you get a message from EVAC announce at freelists.org, you can't reply to that. If you reply, it goes to Never Never Land. So I'm trying to take the email addresses to people who sign up and send them just personally so people can reply. Okay, I think that's the only ways, 4 ways. Okay, good to know. Thank you.
Okay, Tom, thanks. And Bob Buchheim.
Thank you, Claude. Audio check, is that okay on the Zoom? Okay, because if my voice fades, throw something at me. When we look through our telescopes, we see a lot of fascinating things, from the craters on the moon and the rings of Saturn to the swirls of galaxies far, far away. And admit it,
somewhere along the line, you have wondered, can the observations I'm making have some sort of a contribution to science? The answer is a little complicated, but it is not no. Divide the objects and the phenomena that you see in the sky along 3 axes. On the vertical axis, is it invariant, constant, or does it change? On the horizontal axis, as it changes, what's the characteristic time scale? Is it minutes or hours or days or years or decades? Okay, I just got an untitled poll on my screen. What should I do? Close it? Well, okay, it's not up there. Don't worry about it. Thank you. In and out of the page is the question of, is it faint or is it bright? And part of the key to our ability to participate in and contribute to astronomical research is that dimension. At the professional observatories, well, that's not working. No, the down arrow doesn't work. How do I make it go forward? Am I supposed to aim this at something? Yes, it did not go.
All right, then just to, here, you have to click that, or page down, or enter.
Well, perfect. That worked. Enter works. I'll do that. Thank you, Claude. At the professional observatories, there are a very few instruments badly oversubscribed, which means they're controlled by time allocation committees, and they were designed to make precise measurements of faint objects. So they live down in that corner. If, on the other hand, you've got an idea to measure an asteroid rotation curve and you say, I'd like this telescope to make continuous series of images, one every 2 minutes, all night, every night for a couple of weeks, you'll never get a proposed approved to do that. We, on the other hand, own the bright sky. The Vera Rubin telescope's going to be coming online in the not too distant future. That sensor will saturate at magnitude 18. That's fainter than anything we can see, and that's the brightest that it's going to be able to measure. So we own the bright sky, where, for example, asteroids rotate and their light changes on a time scale of minutes to hours to days. There are a myriad of transient events that are poorly observed. There are nova, there's the occasional bright supernova, there are outbursts of various kinds on different kinds of stars. There's a whole zoo of variability in stars and stellar systems that is poorly understood. You can see double stars in their orbits, which turns out to be the only way that you can actually measure the mass of a star. We can do all that because we can devote all night, every night. We can squander our observing time however we want. We can collaborate across longitudes. You know, if there's an object like a cataclysmic variable star that needs to be kept under 24-hour surveillance, we're here in Arizona, we get a friend in New England, another friend in Old England, another friend in India, and one in Japan, and one in Hawaii, and the sun never sets on our network. And things like that have been done for cataclysmic variables, for asteroid light curves, a variety of subjects. And there are more of us than there are of professional astronomers. So yeah, within that part of the graph, our part of the sky, our observations actually can make a useful contribution to science. One of the groups that gets together to share and talk about this is the Society for Astronomical Sciences. We just finished our annual symposium in Southern California 2 weeks ago. It's a gang of mostly amateur, some professional astronomers who are doing research projects that take advantage of the capabilities of backyard scale instruments and CCDs and spectrographs. Day one was filled with presentations on stellar variability, stellar photometry, planetary weather, narrowband imaging of Jupiter, binary stars, and atmospheric effects. And day two continued with stellar evolution, the design and use of amateur scale spectrographs, flares on stars, and applications of CubeSats to astronomical research. Prior to those 2 days of technical papers, we had a day of workshops, which for me was a really interesting highlight. I had asked some professional astronomers to come and talk about projects they wish somebody would do that fits into our part of that graph, and for that reason are flat out not being attended to. Tom Macarone from University in Texas talked about Cygnus X1. Has anybody here looked at Cygnus X1? It's a one star and one black hole system going around each other. The gravity from that black hole distorts the star into a sort of an egg shape. So as they go around, the brightness changes on a cycle of 6 or 7 days. And you can see it in you can image it with your CCD and do photometry on it and measure that brightness cycle. His idea is, because you've got a relativistic object in the black hole, monitoring that for the next several years and look for a period change in that orbit that can be then correlated to the predictions of general relativity with our kind of gear. Then I asked Brian Warner and Al Harris, shown on the bottom, two of the deans of ground-based asteroid studies, to what would they like to see people do more of? Rotational light curves of asteroids, well done, betray non-gravitational forces on those objects. Asteroid phase curves, which is how the brightness changes as the angle between Earth, Sun, and asteroid changes, give you surface properties of the object. And now that Arecibo is out of business, monitoring near-Earth asteroids is kind of up to the optical guys again, us. Arnie Hendon pointed out, we've all heard of Cepheid variables, right? Polaris is one, and it's not acting the way a standard candle is supposed to act. The amplitude of its pulsations has gone down, 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 and might be going up again a little bit, but it needs a regular cycle of observations to figure out what's going on out there. He's also begun the all sky something photometric survey. I don't remember what APAS stands for, and needs remote observers interested in photometry to operate the remotely operated telescope setups. And David Boyd came from England and talked about how combining small backyard telescope spectrographs with small backyard telescope photometry can make an enormous contribution to understanding pulsating and erupting variable stars. So we all went home with plenty of things to do. There were a few East Valley participants, John Wetmore at the top, Woody Sims on the left, Bob Denny, you may know from DC3 James here in Mesa, and Tom Palakis, whom you know from his asteroid light curve studies, and a cast of thousands. There were 60 people in the auditorium and another couple of dozen joined online for the entire 3-day series. It was a lot of fun, and we all learned a lot. Here's everybody. If you're curious about how to do this, how to contribute to science, the proceedings book from this year is freely available on the SAS website, socastrosci.org. The videos of all of the talks will be available on our website shortly, but the playlist is available now on YouTube. On that table over there, there's some little slips of paper that have the address so you can watch the technical presentations on video. And on that little table over there is some of the prior year proceedings books. Please look through them, take one home, give it to a student, you know, get it out of my cabinet. SAS 2023 will happen in late May, early June next year in Southern California. It will again be a hybrid session like this meeting is, both online and in-person participation. If you're interested, join us. You don't have to be an expert. This is the place to come to get a little bit interested, a little bit indoctrinated, and a little bit educated, so you too can start contributing to these research projects. So the answer to the question is, can we contribute to astronomical research? The answer is yes. Go to that website to learn more. Also, in the room is my neighbor, Phil. He's in the back, turn around, raise your hand again, Phil. If those of you who are observers would introduce yourselves and sort of embrace him into the community, give him the secret handshake, because you know what's going to happen. If I'm the one who teaches him about astronomy, he's going to be doing asteroid light curves. So thank you very much for the time at the podium. I will hand this off to our next speaker.
Thank you, Bob. That was a very great presentation. So it does seem to be working now. So Sid is a member of the EVAC club. He joined just before the pandemonium. So he now is attending, I think, what, your first live presentation? Third live presentation. All right, perfect. And he is going to be speaking to us about astrophotography, starting the way many of us have started, or that many people are interested in from the very beginning. Bob has a long presentation, and so we're going to cut that in two. So Sid is going to be our speaker for July as well. So this is part one of astrophotography, and then part two will be next month. So Sid, take it over. And again,
Magic controller, right
and-
or left? Got
yeah,
it.
this one would be forward and that one's back.
Thank you. Well, definitely astrophotography is a journey and it's not a sprint. I'm Sid Frede. I'm an amateur astrophotographer, and that may sound like somewhat of an admission of an addiction, and really perhaps it is, because once you get engaged in astrophotography, it becomes very much that type of a situation. So I must admit that I am an astro junkie, and with that in mind, let me talk about a disclaimer before we get started. The following document is comprised of sometimes incoherent ramblings of a wannabe astrophotographer. The opinions are solely my own, sometimes actually based on fact, but mostly a compilation of pieces of knowledge which may or may not be correct. Experienced astrophotographers. Okay. Experienced astrophotographers may cringe at my process or conclusions. If so, I ask for your help. I have made the journey with the help of various friends, forums, Facebook groups, and YouTubers worldwide. And I have a process that pleases and challenges me, and really isn't that the purpose of a hobby to begin with? I feel like I'm drinking from a fire hose, and I'm excited about continuing my quest for knowledge and competence. Before I get started, I'd just like to say that I am honored and humbled to be here tonight to present to you, because typically the major presenter at our meetings is a research scientist, an astrophysicist, an engineer, someone who's working with some of the cutting edge aspects of our hobby and working with a very expensive equipment sitting on top of an observatory in Chile. Well, mine is a observatory in my backyard in downtown Tempe. I'm in borderlate skies at best, and probably worse. And the entrance to my observatory is the back door to my patio. So that's my home. I really talk about three phases of astrophotography: being capture, calibrate, and create. And image capture is really what I'm going to be concentrating on tonight. And this is a physical aspect of the hobby: the camera, the lenses, the telescopes, our mount, the guide, the filters, exposures, all those things that are required to, first of all, capture that image to begin with. The second phase of the presentation, which I'll cover next time, really talks about image calibration. And this can be very confusing because we talk about light frames, bias frames, dark frames, flat frames, dark flat frames, flat dark frames. And that can be in itself sort of humbling. And finally, it's a process of creating that image. So next session, we'll concentrate on those areas. Really taking snapshots, making pictures, and correcting images. There's a certain aristocracy in astrophotography. When you first begin, you're taking snapshots. As you progress, you're taking or making pictures. And as your ego swells and you become a little more proficient, you're creating images. So depending upon what type of verbiage we're using when we're talking about the photos we're producing, you can kind of get some idea of where you're at on that scale. So my journey, where does my journey start? I really had an interest primarily in deep sky photography, in nebulas and galaxies and those far away type of deep space objects. Planetary photography is very different, has different tools, takes a different knowledge set and a different expertise. I have no experience or competence in this area, but that's something that I'd like to explore as I have a chance to concentrate on that later on. So a shortcut to success, take lots of pictures. You can stack those pictures with some fairly inexpensive software. In fact, this particular software is called Deep Sky Stacker. It's free. We can click and process that image with Photoshop or some type of image processing software, and voila, you got some type of an image to enjoy. You achieve success, and you completed your first heavenly image. That's pretty much it. You're done. Great pictures, great fun. That's easy as can be. Well, maybe not quite so. What will happen, though, is that your family's going to be amazed because they love you when they look at your pictures. Your friends won't understand, and they'll just say, well, you know, that's nice. And you have to accept that because that's what's going to happen. Beginning a journey. I have a history with the DSLR. Back in the 70s and 80s, I took a lot of black and white photographs. I'd buy film in 100-foot rolls and then fill up those little 35-millimeter canisters. Remember those? We used to have those, yes. I would have those in my pocket in my car and took them with me everywhere and shot a lot of monochrome black and white images. I then locked myself in my bathroom in our little small home in our single bathroom with the noxious chemicals. It would probably peel the paint off the wall. My wife was very tolerant, and I'd spend hours in there and developing my film and developing those photographs. As time moved on and digital photography started to occur, I had a Canon digital camera. And in fact, this Canon digital camera, the Rebel TC3i, is one I still have today. And that was my first astrophotography camera used on my telescope systems. I'm pretty much self-educated in that area. I did a lot of reading about composition, layout, color, exposure, ISO, minor experience with RAW and Photoshop, and basically consumed a lot of information, learned a lot about how to do black and white photography at the time, but really it applies to all types of photography and creation of images. Had an interest in the night sky. We had a boat. We spent a lot of time at Lake Powell in the 80s and 90s. And when my son was young and growing up, we'd sit on the deck of the boat at night with our star charts and look at the beautiful skies in Lake Powell, looking at the constellations and occasionally some meteors and the deep sky objects, and just incredible sight, at least Bortle 2, maybe better, and just a night sky that you just couldn't believe. So both my son and I at that point in time had developed a great love for the sky. And just the immensity of the universe we're talking about and the distances we're talking about, literally millions of light years, it's just something that's hard to get your head around and try to understand really what the whole night sky is about. So when my son was in about the 5th grade, I bought him a scope for Christmas. Well, really, I bought me a scope for Christmas and I allowed my son to use it. But together, we explored the night skies. I got a recommendation from a Mesa telescope shop and bought a Meade ETX LS6. It's a nice little 6-inch Smith Cassegrain telescope. And it's basically all computerized. All you had to do is to turn on the power switch. It would, GPS would locate itself and determine where it's at. It'd go through a plate solve and self-alignment, and in about 5 minutes, it was ready to go. It had a tonight's best list, which would basically take you a tour of the sky. And as it took you a tour of those skies with various objects, it had a really, really good audio file. It would talk about what that object was and some of the technical details of that object, and then take you through the night sky of those primary objects that particular evening. It was a fabulous go-to scope. We used it a lot. It was a great way to tour the heavens, really get some feeling for what the objects were that were available to take a look at. But life got in the way. Other interests, you know, my son moved into middle school and high school and baseball and sports and girls and cars, and other interests kind of took over. I was pretty busy at work. I had my own business. I was doing a lot of traveling, and basically life got in the way and sort of distracted from us from pursuing some of the astrophotography aspects of the hobby. But had some renewed interest. My son and I, we maintain interest in the night sky. We both had apps on our iPhones so that we go out at night and you could track some of the things that were going on and follow some of the astronomical events. So we never really lost touch with the beauty of the night skies. My son graduated from college. I'm happy to say he got a master's degree in aerospace engineering. And I'd like to think maybe that some of our experiences in viewing the heavens and studying the heavens and flight and everything else involved helped him influence maybe his choice in careers. I was at the point where I was getting ready to sell my business to my partners, kind of preparing for retirement. And I got enthralled with really looking at all the Hubble photos and the magnificent photographs that were available to see from the Hubble area. And my engineering background kicked in. So I joined EVAC in November of 2019, had a chance to attend a couple of meetings, met Gordon, and we talked a little bit about things going on in the club. At the time, I was president of East Valley Aviators. So we talked a lot about the commonalities of the clubs and the responsibilities of running the clubs. And then COVID struck, of course. And we went to remote meetings. So like a lot of other people, I dusted off my scope and I joined the backyard COVID astronomers. Well, I got a little bit bored of just looking at bright stars or like little white dots and blue dots and yellow dots and other types of things. And I said, wouldn't it really be great if I could take some pictures of those? So I bought an adapter for that little Canon digital camera that I mentioned before and stuck it on that Meade telescope and started taking some individual photos. Well, the first obvious target is the moon, because it's easy to find, and that's really important when you're trying to find a target to shoot. It's also very bright, so you can take a very short exposure. So with a single exposure colored DSLR, you can get a lot of beautiful photographs of the moon. The next thing I wanted to take a look at was the M13 Hercules cluster. Literally thousands of stars, but when I looked at it through my telescope, it was just kind of a furry tennis ball. In those border late skies in my backyard, it was very difficult to really see what was there. So that was kind of an aha moment for me, because at that point in time, I realized that I really need to take some longer exposures to capture the glory of some of these deep space objects. So we're back to those three phases again. We're back to the camera, the lens, the telescope, and all those mechanical things we have to put together to be able to take those photographs. This is my first photo. Anybody recognize what it is? It's Orion, horribly out of focus, but this was a photograph that got me started. When I saw this photograph and I got the color, I thought, well, I'm on my way. This is absolutely gorgeous. And not knowing, but if you take a look, recognize what that is? That's the trapezium in Orion. And that's something that when you're working on a photograph of Orion that you desperately try to expose, because with the dynamic range of Orion, it's very bright and very dark. And it really takes a lot of processing to bring that out in a good photograph. So unknowingly, my very first photographs, I stumbled on that without even knowing what I was doing. But this is what got me started. This got me hooked. So M13, though, I really needed a longer exposure. And I had this, the Altaz mount on this observing scope. And for about 30-second exposure, I could probably do okay. But anything much more than that, I get star tracks and trails. And so what do I need? I need an EQ mount. Well, what's the difference? And why do I need an EQ mount? Maybe I can try something here. Basically, if the Altaz mount has 2 axes of rotation. The Altaz mount has 2 axes of rotation. I can rotate from 0 to 360 degrees. And I can change the rotation of my scope vertically and get the declination. So what that does for me, let me put this down. As my scope rotates this direction and the scope changes elevation, and as a target crosses the sky, the target moves something like this. It starts out in the east, it follows the north celestial pole, and it goes over and disappears in the west. Well, my camera is pointed one direction. So at this point in time, I'm taking this image, and by the time I get over here, I'm taking this image, it's inverted. So all along the way, if I try to take an exposure, my target is moving or it's rotating as I'm going across the sky. That does not allow you to take a good long-term astrophotograph. Well, what does an EQ mount do? Well, an EQ mount does something like this. We basically orient the mount at 33 degrees, which is the elevation here in Phoenix. So we point the arm of the equatorial mount towards the celestial pole. So now the equatorial mount rotates around that celestial pole. So now when I'm tracking an image, as I track that image, my camera rotates with the image. So now I can take a long exposure without having any rotation. And the only limitation is how good is my guiding to track that star, that item across the sky. So I said, well, I got to buy an EQ mount. Well, as it so happens, at that point in time, Celestron had a sale. They were basically taking $500 off of all their edge telescopes. Well, I thought, well, you know, bigger is better. They've got an 8-inch, they've got a 9.5, they've got an 11, they've got a 14. And at that point in time, I really had no concept of the difficulty of imaging with long focal length telescopes. But I said, well, I can figure it out. You know, I'm an engineer. I understand math and physics and semiconductors, computers. How hard can it be? Well, it can be hard. So I bought an Edge 11 and the equivalent equatorial mount, the CGM 2, on the very last day of the sale on April of 2020, expecting that I was going to have my toys here quickly to play with. Well, at first it was 30 to 60 days or so for delivery, and then it was 90 days, and it was, we really don't know when we're going to get them, so hurry up and wait. So we entered into the push out of all the astronomical equipment that we saw during the pandemic. So during that period of the 5 months that I was waiting on delivery, I basically read every cloudy night thread that I had that could pertain to my particular scope and my setup. I read the manuals backwards and forwards on my telescope and on the mount. I went through numerous YouTube videos to the point that I kind of became a virtual expert without ever having touched my scope. And I found myself answering people's questions online on the Facebook page by educating themselves by what I'd learned by not doing anything. So you got to be careful who you listen to online because they may not know what they're talking about. Whoops. So buyer's remorse started to set in. I basically said, well, I had no idea what I was getting into and what have I done. I'm really gotten in over my head. Everything I've seen on the internet and YouTube says what I'm trying to do is going to be very difficult. What I should have done is I should have bought a smaller scope with a smaller focal length and a wider field, which would be ideal for the nebulous, which I was really interested in photographing. They're easy to focus. Guiding is not as critical. They're smaller, they're lighter, they're easy to handle, less expensive accessories, easy to transport to take out to a dark sky site. Really a much better choice than what I made, but I'm stuck. I've got to figure out what I've got and make it work. So I read the mount manual backwards and forwards many times. Basically, I virtually went through the connection of setting up my telescope, setting up the mount, and doing all my electrical connections, doing the alignments, or learning all about the hand controllers, setting up my power connections, my USB connections, and doing all that before I'd ever had a chance to touch any of the equipment. With large focal length scopes, off-axis guiding is something that's highly recommended. So in working with the guys at Starzona, who I bought my equipment from, this is what they initially set me up with. So the problems that you're involved with is that basically you're guiding at the focal length of the scope. So rather than a 50 millimeter or 100 millimeter guide scope, I'm guiding with a 2800 millimeter scope. So you have a very small pickoff area to pick the stars to guide with. That can be a problem. And the focus is very critical in setting up the off-axis guider. Well, James Lamb, bless his heart, is a renowned YouTube tutor. He has an excellent discussion of how to set up an off-axis guider. You have to be a little patient because he's the kind of guy that if you ask him what time it is, he'll tell you how to build an atomic clock. So if you can wait through that and you get to the end of it, there's great information. So I basically follow his guidance and, you know, excuse the pun on that one, but he essentially told me how to set up my off-axis guider. And also now focal length or prime focus is a very critical issue when you're talking about setting up a telescope. For my Edge 11, it's a very important distance from, this is the back of the last piece of glass at the telescope, whether that's the actual telescope itself or the focal reducer, but that's the last piece of glass in the telescope. That point to the sensor, whether that's a sensor in my DLSR or whether that's a sensor in a dedicated astro camera, for this setup and this camera and this telescope is 146 millimeters. Now, if you add a filter in there, that adds about another millimeter. So you have to be pretty much exactly 147 millimeters from here to here. Well, the off-axis guider and the connectors and the couplers and the filter wheels and all those are all very specific distances. So what you have to do then is you can make this up with spacers, and whatever is left over to make up 147 millimeters, you stick in here to get the exact duplicate, exact information. Again, Starizona was extremely helpful for me. I basically sketched out what I thought was correct. I sent that down to those guys, said, well, you're almost correct, but here's what you need to do, and here's the spacers you need, and here are the connectors you need. So they basically took care of me, set me up with the right stuff. So when I went to put the thing together, it worked. Very important. I mean, dealing with the local vendor is extremely important. I highly recommend that. So mechanical configurations. Now I'm going to try to set my system up. I've been delivered, I picked up my telescope, picked up my mount and all the other peripheral items. So I'm back in my backyard in my observatory now, and I'm setting up my telescope, trying to align it as closely as possible to north. And there's a locator pin on the tripod that allows me to do that. And then level it as closely as possible so that I've got a good solid base and a solid location. My wife is very tolerant of taking up the space on my patio, and I basically reserved that since I set up my first telescope. One critical issue is securing the tripod legs. I thought I had the tripod legs very, very tight when I tightened them up, but I found that when I first put the system together and put my scope on, one of the tripod legs collapsed. Luckily, I was able to catch my scope before it plummeted to the ground. So I built myself a little built-in wrench that I duct taped to the toe of the one of the arms of the tripod. And this time I tightened it down to the point where I will probably never be able to get it loose again, but I'm sure that it won't collapse. Now also, if you take a look at, this is the base of the tripod, and I've got my mount that goes on top of that. One of the threads that I saw on Cloudy Nights was saying that this particular configuration, this is not a highly machined piece of material. There are burrs and spurs that's not very level sometimes. And what you can find is that when you're trying to make the adjustment, it basically sticks and jumps and sticks and jumps. So a lot of the threads said, well, you can take Teflon pads and attach them and do this and do that, but they wear out and they compress, or you can do this or you can do that. And one guy said, well, just take a bar of ivory soap and rub it hard around the surface on this, and rub that same bar on the top of the mount, and you stick them together, and they'll be as slick as can be. And it's worked perfectly and never failed. Very simple solution. So sometimes the simplest is the best. All right, so now I'm attaching the mount to the tripod. And really the only critical factor there is making sure it's tight. And I learned that lesson. And also to basically adjust approximately the declination angle to about 33 degrees, which is what we're at here in the valley. And you'll find that those mechanical guidances are pretty close. They're usually 2 or 3 degrees close. But once you get it close, then the software, when you start to do your alignment, will take care of the rest. Now, mounting the scope to the mount itself. That was, again, something that was a little bit harrowing, because the Edge 11 is about a 30-pound scope. So I'm trying to balance it up there and get it on the rails and make sure I can get it tightened down real hard. And again, I may not get the scope off because I tightened those knobs so tight because I didn't want the thing to slide out of there. But I got it mounted. And then once it's mounted, you have to balance it in both directions. And there's really some excellent YouTubers on board that talk about how to very accurately balance your system, and very easily. So these couple of guys do a great job of telling you how to get that balanced. Software drivers, you have to be able to talk to all these pieces. ASCOM is a universal software driver, basically allows you to connect your hardware to your computer. There's an industry standard platform that you can download. And then typically most of your vendors, the camera vendors and other vendors will have their particular ASCOM drivers that you can download from your vendor, install those on their computer. So now you have a chance that your computer will talk to all the pieces of your system. So basically for me, I really haven't had an eyepiece on my system since late 2020. It's all been done through the camera and the computer. Occasionally I will put an eyepiece on when I have some people over to do some star hopping and take a look at some stars. But other than that, my camera and my computer sits on my system, and I barely ever take it off. Electrical connections. Now this is a part that was easier for me. My background is electrical engineering, so this is the part I understand. Basically, I've got a USB hub on the system, a powered USB hub, and everything plugs into there. My camera plugs into there, my scope plugs into there, my focuser plugs into there, my filter wheel plugs into there, and I have one USB connection coming out to my laptop PC sitting on my patio table. I also have a power strip that's attached to the tripod, and I have a cord coming out from that to my PC. And if you'll notice this right here, That's my universal tripod tightener. That stays there forever. And it's it's a 6-inch piece of pipe that I stick over the top of this knob and make sure that it's really, really tight. I did something wrong.
Sid, could you go back to the, your tripod tightener and maybe just the mouse?
This is just a 6-inch piece of pipe. It's big enough to fit over that particular wing.
I mean, for the Zoom people, they can't see your laser pointer. So it's the little thing at the bottom of the tripod.
Yeah, can I just point to it?
No, yeah, no. With the mouse, you can point to it. Yeah, there you go. Yeah, those guys.
Yeah, that's just a 6-inch piece of pipe that I use as a lever to make sure it's tight. And it stays right there. It's duct taped to my tripod. Now, mechanically, my system is together. The scope's on the mount's connected to my computer, my drivers are there. I can talk to all my pieces on my scope and my mount. And now I need to do an alignment so I can actually find the items in the sky. There's a couple pieces of alignment. There's a go-to alignment and a polar alignment. And a go-to alignment is basically something that you achieve by most commonly using the hand controller that comes with the particular mount. And you basically go to maybe 3 different stars, locate the star, then center the star, and then the system remembers that. So if you want to go now to another item that's somewhere in the heavens, it has established itself and it knows exactly where to go. You can continue to add a couple of stars as you go for continual refinement. And what you'll find with only a few stars, when you do a go-to an item, it will be exactly centered in the eyepiece or exactly centered in the camera. Works very, very well. All the mount vendors have that in their hand controller, and that's pretty easy to do. Now, polar alignment is something a little different. If you're taking photographs, as I mentioned before, it's important to have your scope aligned with the North Celestial Pole so that when you track an item through the stars, you're exactly centered concentrically on the North Celestial Pole. There are a number of ways to do that. It's again primarily handled through the hand controller. There's also other ways of doing it. I use Sky Safari as an application on my iPad, which is basically a planetarium application, and it connects via Wi-Fi to my mount, so I can do go-to alignments and polar alignments from my iPad and talking to my mount. So polar alignment is basically, again, we're pointing our mounts such that we're pointing towards the North Celestial Pole. And it's really pretty easy to do if you can see the North Celestial Pole. There's a number of ways to do that. Pole Master happens to be a little camera that attaches to the front of your mount, and you have a little piece of software that runs on your computer. It's very quick and it's very easy and very accurate. SharpCap has an alignment process, and there's a whole myriad of ways to do that. It's really pretty simple when you can see the North Celestial Pole. Unfortunately, my arrangement is that my neighbor has a tree that's blocking the North Celestial Pole. Now, he was not interested in cutting down the tree so that I could photograph at night. And I decided it probably wasn't good for neighbor relations to sneak over the fence at night and do some trimming. As it turns out, there is a number of programs that are available to get a polar alignment without having to see the North Celestial Pole. Celestron has one of those. Works very, very well. It's called All-Star Polar Alignment. PHC2 has something called drift alignment. And again, there's a whole myriad of applications that will allow you to do a very accurate polar alignment without seeing the North Celestial Pole. I currently use a program called Nina, and it has a very accurate process. It's basically automated to do that very orientation. So I'm connected, my scope is working, I'm go-to aligned, I'm polar aligned, I can zoom around the heavens and I can see a bunch of stuff. So basically the first 6 weeks was observation only. I really got familiar with the mount. A little faster. Got familiar with the mount and the eyepieces and how to do the alignments. Did a lot of go-tos to find out all types of objects in the skies. Set up a procedure as to how to set up and tear down my scope, and then store it and store the equipment. and basically automated this process of effectively setting up, turning on, observing items, and then storing and putting things away. Again, I spent about the first 6 weeks of doing that, getting really familiar with the equipment before I tried to take the next step. And the next step is to take some exposures. And again, to take some decent exposures, you have to be able to take some longer exposures. And to do that, you've got to be able to accurately track that object across the sky. So you've got to provide guiding assistance to the mount as it follows that particular object. First of all, you have to be polar aligned to get that started so that you can accurately track that. And that brings us to guiding. So remember that off-axis guider? Now we're really ready to fire that up. So this is basically my system back here. This is my telescope. This is actually a focal reducer. So this is the last piece of glass on my telescope. And that distance to the distance of the sensor in my camera, this is my DLSR, is 147 millimeters. This is the off-axis guider, and this is the guider camera. So it's very important that the distance from this sensor to the prism, which picks off some of the light stream to be able to find the star, and the distance from the prism to the sensor in my guider is the same. And you can see a little black mark there on the guider. That's the position of my sensor. So this distance from the camera sensor to the prism, and from the prism to the off-axis guider cam have to be exact. And when that's set up, it becomes very easy to focus. And if we can do that on the screen, I guess here. My sensor and the camera sits approximately here. The pickoff prism that takes a stream of light out of the telescope is about there. And that little black mark on my guide cam is where the sensor sits on the guide cam. So the distance from that sensor to the prism and the distance from the prism to the sensor in my camera have to be exactly the same. And if they are, the off-axis guider is very easy to set up. And now that the guider is set up, we need software. And there's a software package called PhD2, and it stands for Push Here Dummy. And it really is a one-button kind of guiding package. There's a very extensive background of best practices, how to analyze your guiding results, a very extensive website that talks about PhD2 and the manuals associated with that. But basically, it's intended to set it up, install it, push the button, start the guiding, and you're off. And from there, you can start to fine tune and play with it. But really, for the most part, it sort of works out of the box. It's a great piece of software. It's free. It's very well supported, and almost everybody uses it. And this is what a graph of the actual guiding might look like. The red chart, I'm happy with the buttons here. The red line is basically our declination. And this happens to be a superb graph that I copied. You don't often see them this clean. And the blue line is the RA axis. And occasionally you can see a blue pulse here. And that occurs when something gets out of line and the software sends a pulse to the guide to try to bring it back into center. So all through the night, the software is going to be sending pulses to the mount in order to make sure that your target is centered. Now imaging. As I mentioned before, I started imaging with that good old Canon DSLR. It was a great tool. It takes great pictures. The CMOS sensors in those digital cameras are very, very good. They make powerful astrophotography cameras, and most people already have one, whether it's a Sony or a Nikon or a Canon. You can basically get an adapter that will allow you to connect that directly to your scope and start taking pictures. You can modify those to make them even better for astrophotography. Typically, that modification costs several $100s. And my recommendation is save your money there and go spend it on a dedicated Astrocam later. Because if you do modify your DSLR, that limits its ability to take normal pictures during the day and everything else. Now, a dedicated Astro camera. Why buy a dedicated Astro camera? One primary reason in that it's a cool sensor. So what that means is it allows you to cool the sensor on that camera down to mostly of them are like 35 degrees C less than the ambient temperature. And what that does is it significantly reduces the amount of noise that's contributed into the image by your sensor itself. So every time you turn on that sensor powered up, you've got electrons flying around at the speed of light. And there's a basically inherent noise in that sensor. And it generates hot pixels and shot noise and all sorts of other things that you basically have to calibrate out. So If you can cool the sensor, you significantly under that contribution of noise from the very beginning, and it makes that whole process much easier. There's a large selection of them, a lot of different vendors, and they're very reasonably priced. This is the first Astrocam that I bought. It's from the manufacturer ZWO. It's the ASI 533 MC Pro. It's a color camera. So every pixel, just like the DSLR, has a red, green, and blue sensor. So it takes a color image every time that you get exposed to a pixel. It has the cool sensor. Again, you can cool it down to about 35 degrees C below ambient. So it greatly reduce that noise. And it's really a marvelous camera. You can use mono cameras, which I'll talk about a little bit later, but certainly in doing your initial astrophotography, I'd really recommend using that DSLR. It's a great tool. Get used to that. And as you migrate to a dedicated astro camera, pick out a good dedicated one-shot color cam, and you'll be very satisfied with that. Focusing. If you're not in focus, you're recording garbage. So no matter how good your system is or how good your scope is or how good your tracking is, if it's not in focus, you got nothing. So remember that first photograph I had of Orion, the one that I was so proud of? The focus was horrible. So how do you get in focus? Well, there's several methods. Is that my particular scope has a very small knob of which I can control to do my focus. And that's very difficult to get an accurate focus and trying to twist that knob with your thumb and your forefinger. Well, you can order and add to that a Feather Touch focuser for $300 or $400, or you can just stick a clothespin on there. And basically that gives you a long lever arm. So now you have a very fine and very accurate focus. It does everything that this $300 focuser does for just attaching a clothespin to your focus knob. So you can go to a bright star and adjust your focus until you get the smallest possible star in the frame that you can see. And you can also use something called a Batinoff mask. And this really gets back to good old physics, and it's basically a diffraction math that gives you a diffraction pattern when you put it over the scope. And you can see that in the center, that diffraction pattern is exactly lined up. Come back here. And off to the side, that diffraction pattern is slightly displaced. Well, when you line that diffraction pattern up directly in the middle, that's probably as accurate as a focus as you're ever going to get. The Batinoff mask works very, very well. It's very accurate. In fact, you use that to check the accuracy of your automatic focusers. Now, if you're doing astrophotography over a long period of night, and ideally you'd like to be able to start photographing when the sun goes down and photograph your targets until the sun comes up and get the maximum amount of time on target, you're going to find that during the night, the temperature will change. And as the temperature changes, the focus will change. Also, seeing conditions will change during the night as temperature changes and the atmosphere changes. And the position of your target as it passes through the meridian, which is directly above us, you're now shooting through the minimum amount of atmosphere. So you get the best possible viewing, the best possible seeing, versus when you're shooting lower in the sky, shooting through higher atmosphere. So you're going to get more degraded focusing. So you can do a couple of things. You can go out every 60 minutes and do an autofocus. Just tell your focuser to go do a focus. And that works fine, but that means every hour on the hour all night long, you've got to be out there to do the focus. So most software programs have the ability to do some type of monitoring of autofocus. But the program I'm using right now is called Nina. And what you can do is you can set up an autofocus that says if my focus varies by like 8% from where my target is, I'll call up an autofocus. And I won't waste time doing an autofocus. So some nights I might do a focus 3 times a night. Very minimal. Seeing is good, temperature is good, everything is stable. And some nights that autofocuser might do 15 type of autofocus runs when the situation is not so good. Well, how does the autofocus know when it's in focus? Well, if you take a look at this particular curve, the lowest possible computation it can take a look at is either called usually a half flux diameter or another parameter. But basically you start at this point, mechanically the focus will change some distance and it'll take another reading. It'll change additional distance, it'll take another reading. It'll change more distances and take another reading, and it'll come to the other side and do the other direction. So it'll plot a number of points at a different focusing distance off a center, and from that, it will then plot a parabola and determine that the parabola is the lowest possible point at this point, and that's your best possible focus. And then it adjusts the autofocuser at that point, and you're off and running. And then when the autofocus or when the focus changes during the night, it calls up the autofocuser, runs through the same thing again, and calculates a new focus point. And for me, this will take about 3 minutes to do an autofocus run. So you're not wasting much time during the night to image. And again, some nights it'll only run 3 times, and other nights it'll run maybe 15 times doing an autofocus. But again, if you're not in focus, you're recording garbage. Exposure. Boy, now we get into politics and religion. This is probably the most argued point in astrophotography, is what is the right exposure? And the right exposure is basically when it's enough. Well, how do you determine that? Dr. Robin Glover is a well-known member of the astronomical community, and he actually is the inventor of Sharp Cap. There are a couple of YouTube videos, each about an hour long, which he goes into excruciating detail about how to obtain focus. And he wastes no bones about getting into the physics and the mechanics of calculating what that is. But basically, what is the best focus? The best focus is what you can obtain. In highly polluted light environments, like my backyard in Tempe, you tend to take a lot of short exposures, and you take a lot of them. Because what you find is that if you take a longer exposure, the light pollution greatly swamps out this very small photon count you're getting from the target. So if you're in a dark sky situation, you can take much longer exposures without the light pollution affecting that. So it becomes kind of a situation as to what your environment, as to what your exposure is going to be. Longer exposures will saturate the whites. Well, what that means is that if we've got a bunch of stars and we have some very bright stars at the beginning which are already white, chances are we'll have some stars which are blue stars or orange stars or yellow stars and have color in our stars. If we expose too long, we'll drive all those stars to white and everything will be white. We'll also saturate other items in our deep sky object and drive those into white as well. So it's a very delicate situation of finding that right exposure. And also, what we really counteract that with is filters, and I'll talk about that in a moment. But basically, what I do in a lot of my exposures is I've got some particular exposures I found that work for me in my backyard. Typically, when I'm shooting red, green, and blue filters or color filters, I'll take either a 60-second exposure or maybe a 120-second exposure and push it. If I go much beyond that, I find that the light pollution starts to overwhelm my picture. When I'm shooting narrowband filters, more restricted, I'll typically shoot 300-second exposures, and in some cases 600-second exposures. But and taking a look at filters, that's what we're talking about. Well, basically, experiment. And that's basically what I did to achieve what worked for me in my backyard. But really, a key thing is to ask somebody. We've got a lot of experience with people who've been there, done that. People are local vendors, EVAC members, friends, Cloudy Nights, YouTubes. And again, I depended upon Star Arizona in many cases to talk to them about what's the exposure? What should I be doing? They've got a limited experience with all types of scopes and filters and light conditions, and they have a wealth of knowledge, and they're always happy to share it. They're just like us. You get a guy who wants to talk about astrophotography, you can't shut him off because we're all talking about things that we love. Color palettes. And getting the right exposure and getting the right colors. This is the very famous pillars of creation in the Hubble palette. And when we talk about the Hubble palette is basically, they call it the SHO palette. And that derives from using a sulfur filter and selecting a very narrow bandwidth of light, using a hydrogen filter, selecting a narrow, very bandwidth of light, and using an oxygen filter. As it turns out, the gases in the emission nebulas are primarily sulfur, hydrogen, oxygen, which gives us a bandwidth where we can collect the most amount of light. And what we're doing is we're excluding all this other light, which is light pollution. And even we're taking color pictures with red, green, and blue, whether it's with our DLSR or with our Astro camera. Typically, we have a gap here that's left out, which is typically the area where we have the sodium vapor lights and a lot of light pollution. But the problem we're having now is that LED lights are starting up, and LED lights can be everywhere. LEDs can be blues and purples and greens and yellows and reds, which really compounds the light pollution problem. And it makes the problem of imaging and light polluted environments even more difficult. And it makes the importance of filtering the light that you're trying to image even more critical. So what do I do? There are a number of filters that you can use which will select the bandwidth of light that your target is emitting. And you can use those filters on your color camera to only accept the light of your target and eliminate the rest of the light pollution. So I use basically 3 filters called an L Extreme, an L Enhance, and an L Pro. and those three are made by Optolong. So let me show you basically what those are. The L extreme has a very narrow bandwidth of acceptance around oxygen and hydrogen. Where's my cursor? Around 7 nanometers or so, which is very specifically the wavelengths that are generated by an emissions nebula. So it's a fantastic filter when you're photographing emission nebulas. The L enhance has a slightly wider bandwidth around those areas. And for those deep sky objects that also emission nebulas, perhaps reflection nebulas, allows you to pick up a wider bandwidth of light that's being emitted. And then the L Pro has a much wider bandwidth around those areas. So typically I use this when I'm imaging a galaxy, because of course a galaxy has stars, it has nebulas, it has dark nebulas, it has reflection nebulas, it has all those components of all that spectrum. So it allows you to pick out those light bandwidths and again, try to screen out any light pollution that will negatively affect your photograph. So basically pardon? Yes. So even though I'm shooting a color camera, I'm really shooting narrowband because I'm using a filter to only allow that bandwidth of light that is that particular target I'm trying to shoot to hit my sensor. I'm trying to exclude the light that I don't want. Now, 4 things that'll make you pro. Plate solve, dithering, the flip, and the script. So let's take a look at each one of those. What is plate solve? Well, years ago, when astronomers were taking photographs of the heavens, they would basically line up to a target and they use a black and white photographic plate, maybe a 4x5 plate or an 8x10 plate, and they would expose a photographic plate to that particular image that evening. And then sometime during the day, a crew of people, and it usually was a group of ladies, would take that developed image and they would take a look at a corresponding astronomical database, and they will know that I was basically pointing at Orion, so I know where I'm close. So they'll take that particular photograph that was imaged that night, and they'll take the astronomical database and they'll say, well, here's the star and there's that star, okay, and here's that star and there's that star, okay, and there's that star and there's that star, and basically plate solve that photographic plate and identify exactly what it is and exactly the dimensions and exactly where it is. And now we've got a solved plate that can be used in the scientific experimentation that the astronomer has collected that particular evening. Well, what happens in our environment? We do exactly the same thing with our computer software. We point to a target, the computer takes a photograph, there's an online database or a database that you've loaded on your computer of that astronomical region of the sky. It does a plate solve and basically identifies what you're looking at, and then will help you center that into your target. It says, okay, I know exactly what this is, but you're not on center. I'm going to issue a command to the mount to try to bring that particular object in the dead center of your camera. And it will issue a command, it will move it slightly, do another plate solve, issue a command, do it slightly. Probably takes 2 or 3 times, and what you wind up with is your target exactly centered in your target. And what does that do? Well, if I'm imaging the same target on different nights, I'd like to have it in the same position. So if I go back a few nights later and want to image the same target, when I go to it and do a plate solve, that target will be exactly centered in my computer again. And I can start taking images and it will exactly match what I did several days before. Or perhaps if I imaged that target a year or so ago and I say, well, I'd like to add some data to that. I had some pretty good data back then. I want to take some additional data. I want to combine those. So if I plate solve and go back and take some new data, that data is exactly the same location as I took a year or 2 ago, and I can combine those pieces of data. So plate solving is almost magic, and it works extremely well. There's a couple of programs called Plate Solve 2 and ASTAP, which are all free. You load those into your software, and they work exceptionally well. Dithering. Well, as I mentioned before, when you apply power to your sensor, you're exciting a lot of electrons, and they're screaming around at the speed of light. Some of the pixels in your particular sensor are not very well behaved. It's not a perfect item and it's not a perfect world. There are some pixels that are very aggressive, and any electron that gets close, they're going to grab it. And they're going to fill up what's called the well of that particular pixel. And when that pixel gets filled, it's white. It's exactly bright. It's always going to be bright because it can't get any more electrons. And what you find is you have something called hot pixels in your image. Well, you need to eliminate those hot pixels when you're going to process that particular image to get those out of there. So if this works, It might be very difficult to see, but if you can pick out a point, there's a whole bunch of little tiny dots there, which are basically hot pixels. And what dithering does is it physically moves them out a very small amount so that the image kind of cycles around that point where there's a hot pixel. And the software then knows and recognizes the fact that when it takes that image, that is a stuck pixel. It's a hot pixel. It's always white. I'm going to get rid of it. It takes out of your processing process and eliminates that particular fault that is introduced by the sensor. Let's see if I can get beyond that. The meridian flip. When we're imaging a target, if we're lucky, we have a target that will pass across a meridian. Because at that point in time, as I mentioned, that's where the least possible atmosphere is involved. That's probably where we're going to get our best possible image, and we're going to have the best possible seeing conditions. Well, now, as we get to that particular point, we have a problem. And let me see if I can demonstrate that. This is my telescope again. So I'm starting in the east, and I picked up a target. And I followed that target all the way to the meridian. And now I've got a problem, because if I continue to follow that target this way, remember, I've got my camera hanging out here, and I've got this tripod leg. So the first thing that happens is I hit the tripod leg with my camera. The camera falls off. The tripod leg collapses, and my scope falls to the ground and breaks my mirror. That's bad. So what do we do to correct that? Well, we have something called the meridian flip. So when I get to this point, the software says, okay, I'm at the meridian. Now I'm going to stop. So I'll stop my guiding. I'll stop my imaging. And I basically do another go-to. So I wait for the target to pass over the top of the meridian just a little bit. So when I do a go-to, my scope now knows that the target's on the other side of the meridian, and it comes back and now it points to that target again. So now the rest of the evening, I can follow that target, the west, all to the point if it actually gets down to the western horizon. So that meridian flip is something that's very critical in the imaging process. Now, what I used to do when I first got started was that the meridian flip scared the hell out of me. So if I had a meridian flip at like 2:30 in the morning, I'd be up about 2 o'clock. So I would stop the guiding physically. I'd stop capturing the image. I'd wait for the target to pass across the meridian. I would then mechanically force it to do another go-to, start the guiding again, start the imaging process again, and go back inside and hope I get to sleep. Well, that was a waste of time. And I finally got to the point where I trusted the software, to the point where the software now will do that meridian flip for me. And let's see if it does.
Can you explain meridian real quick, just to make
Sure. Again, the meridian is that line that's directly overhead that separates the eastern and western side of the sky. So when we get to that particular point, again, we're pointing through the least possible amount of atmosphere, and that's our best possible imaging point. So we talk about the eastern side of the sky being the eastern part of the meridian, and then the western part of the sky being the western part of the meridian. Yes. The Polaris to the south is basically the line that splits the sky. So let's see what happens. This is a picture of my scope late one night, and an image I took with my iPhone. So what we got here is that I've imaged to the point where I'm now pointing to my target, which is just approached the meridian from the east. So I've come this direction, and now I'm pointed to my target. Now I've got to get to the other side so I can follow on the other side of the meridian on the western side of the sky. So let's see if this works. So now the scope is doing a go-to, and this is real time. So it now knows that the target's on the other side of the meridian, and it knows where the target is. So now it's going to point to that target. And at 2:30 in the morning, I think it did an exceptional job of holding my iPhone steady. Yes. And the software recognizes that and takes care of that in processing. So now I've done a go-to, and I'm centering in on the object. So I'll wait about 30 seconds for all the vibrations to settle. And after about 30 seconds in, I'll start a plate solve. So again, I'll look for that target. It will be somewhere in my image plane. I'll do a plate solve, send a couple of commands to the mount to bring the target closer to the center, do another photograph, probably do another plate solve, maybe make some other final adjustments. And within 2, maximum of 3 plate solves, my target is exactly centered in my frame. And you're right, it is flipped now, but it is exactly centered. So my software knows how to handle that and how to process that. So I'll continue imaging the rest of the night. Start the guider, wait about 30 seconds for the guider to settle, start the image plan, and then allow my, so now my scope will follow the target over to the west until I either run out of elevation or I run out of dark sky. Script. All the things I talked about as far as executing that meridian flip and setting up all of the other items can be taken care of by establishing a script in your software program. And almost all software tools will allow you to do that. So for me, here's a typical script for an evening. I'll start a script, punch a button. I'll issue a command to cool that sensor to the temperature that I'm going to image that night. Go to a target, do a plate solve to get on center, and I'll start guiding. I'll start my image plan and start taking images. If it gets to the point where it reaches a meridian, I'll do a meridian flip. I'll end the image plan, stop the guiding, and if the target is now past the range which I can image it, I still got some dark left, so maybe let's go to a different target. So I'll set it up so it'll go to another target, do a plate solve, start that whole process over again, and image to the maximum point of the night until I run out of darkness. And at the end of the session, I'll warm the sensor. That's a very important item because up here I cool the sensor, and then after I'm through, I want to warm the sensor. And that's a period that usually takes about 15 minutes. And it's important not to do that too quickly because you can damage the sensor, you can have moisture form on the sensor, and bad things will happen. So the software is set up so that it will take about 15 minutes to cool, and it'll take about 15 minutes to warm. And when it's all done, it'll park the scope and it'll sit there. So I'll go out in the morning, pick up my SSD drive, take it back into the house, and collect the images that I did the night before. And that one didn't work, but we'll try next time. So image capture, and that's really what we talked about tonight. Next month, we're going to talk about image calibration and completing that with image creation. Here are some links that will be posted on the video that goes on the YouTube channel. But this is just a document that I put together as I was going through and ran into certain things and found certain solutions. I just jotted those down and basically made it tips, tricks, and lessons learned. So that's a link you can go to that shows you some of the things that I ran into and the solutions I found. In the July meeting, I did a 15-minute section on that calibration, which I will touch on briefly next month to go over that quickly. And then last December, I did a 15-minute session that is on the YouTube channel on automation, basically clicking a button and going back in the house and letting the system run itself until the morning. And then also, these are some images. If you're not familiar with AstroBin, AstroBin.com is a website that amateur astrophotographers post their wares, and you can take a look at what other people have done. This is one of the places I go when I take a look at imaging a new item. Like M42, you can go there and you can see all types of situations to take a look at what astronomers have done as far as equipment, how many exposures they use, what filters they use, how many they collected, all sorts of details about how they made their image. And taking a look at that, you can relate to what you're trying to do and use that information in trying to make your image. So it's really, really a good site. Again, it's astrobin.com. And I publish most of my photos up there when I'm complete. Section 2, we'll pick it up next time. But here's some of the ones I have done this spring. These are all basically done with a mono camera and filters. But again, whether you're using a color camera or a mono camera, you're basically filtering out the light you want, whether it's a filter on the color camera or a filter on the mono camera, and then combining those. Probably some familiar items, the Cigar Nebula, the Pillars of Creation. This is one I especially like, the Owl Nebula. The Tadpole Nebula without stars. You can remove the stars in the software and get some different views. One of my favorites is the Bubble. And then the Fishhead Nebula was one that really turned out well. There's a fair amount of oxygen in that nebula. So in my image capture there, I probably captured 3 times as amount of the filter with the oxygen filter as the other filters. So I could get a large influence of the blue when I started to do the processing. And I was very pleased it came out very well. So that's kind of where I'm at right now as far as the image capture side. Again, we'll pick it up next month and talk about the calibration and the final creation of an image. So any questions, I'd be happy to try to field those now, but thanks for being attentive and paying attention.
Over so everyone can hear.
Oh,
But it really is a journey. This has been about 3 years since I got started. I wander around. It's been about 3 years ago since I really kind of started and got hooked on this. So, every time I process an image or capture an image, it's a learning process. And I'm always looking at YouTube videos and what other people are doing and trying new techniques. So by no means is it a completed process. Everyone changes and everyone is new. And I learn something every time I do one. Yeah. Yes.
Not a question, but a comment. I admire your ability to have that scope on a tripod and do beautiful work like this. I had a C11 once, and the first thing I did was put a permanent pier in the backyard. So I didn't have to lift that son of a gun.
I've talked to my wife about that. We're still in discussions on that one. She's not excited about having a pier stuck in the back of her patio. I don't see the problem myself. There you go. Cover it with a dome. That's a perfect idea. Again, thanks a lot. See you next week or next month then.
thank you. Thank you, Sid. That was a great presentation. Now I'm going to try to find this. Couple of shots. So would like to mention that the presentation that Sid gave tonight will be posted on the website. Give Tom and Marty a few days, so next week. But you should be able to find it there. And I think you may want to go through. There were some links that were posted there. There also were some links out to documents that might be helpful to you when you're looking at it. But I know that there's an awful lot of detail here that people would like to spend some time with. So keep in mind that all of the Zoom presentations are on the website.